Have you ever wondered why a computer with a powerful processor can still feel slow when too many applications are open? Here the answer is often RAM. RAM is one of the most important components that determines how smoothly computer can run programs, multitask and handle demanding workloads. What is RAM? RAM is a random access memory. It is primary working memory of a computer where the operating system, applications and currently activated data are temporarily stored while the system is running. Whenever your browser opens, it launches software, playground, play a video, compile code, or run a simulation. The required instruction and data are first loaded into RAM so that CPU can access them quickly. RAM is much faster than storage devices such as SSDs and hard drives, which is why frequently used data is placed there. RAM is a volatile memory because it retains information only while power is supplied. Once a computer is turned off or restarted, all data stored in RAM is erased. Think of RAM as a workbench where tools and materials are kept for immediate use, while the SSD or HDD acts as a warehouse for long term storage. Why RAM is important? RAM plays a critical role in determining the overall responsiveness and performance of a computer. When sufficient RAM is available, applications can remain open in memory and be accessed instantly without delays. This enables smooth multitasking, allowing users to switch between programs without experiencing lag. A system with adequate RAM can also cache frequently used files and data, reducing the need to repeatedly access lower storage devices. When RAM is limited, the OS is forced to move data between RAM and storage using virtual memory, significantly slowing down performance. Therefore, RAM directly affects application launch times, multitasking capability, stability, and overall user experience. Improves system responsiveness. A, respect, a responsive system is one that reacts quickly to user inputs such as mouse clicks, keywords commands, and applications launches. RAM contributes to responsiveness by keeping active programs and data readily available for the CPU. For example, when you click on a browser tab or switch to a document you were editing, the information is already present in RAM and can be displayed almost instantly. If the data had to be fetched from storage, every time noticeable delays would occur. Therefore, having sufficient RAM also the RAM system to keep more data readily accessible, making the computer feel faster and smoother. Enable smooth multitasking. Modern users rarely run only one application at a time. A typical workflow may involve a browser with multiple tabs, a video conferencing application, a code editor, music streaming software, and office applications running simultaneously. Each application consumes memory and together they can occupy a sustainable portion of available RAM. When enough RAM is available, all these applications remain active in memory and can be accessed instantly without sufficient RAM. The operating system must continuously move inactive data to storage and reload it when needed, causing delays and reducing productivity. Reduces dependency on slower storage. Although SSDs are much faster than traditional hardware drives, they are still significantly slower than RAM. When RAM becomes full, the OS uses a technique called pagging or swapping, where some data is temporarily moved to storage to free memory space. Since storage access times are much slower than RAM access times, this process introduces performance bottlenecks By providing more RAM, the OS can keep a large amount of active data in memory, reducing the need for paging, improving overall efficiency. Signs you need more RAM. As workloads grow, memory requirements increase. When a system begins experiencing memory storages, several symptoms become noticeable. These signs indicates that the current RAM capacity may no longer be sufficient for the user's workload. Systems slow with many applications open. If your computer performs well with a few applications but becomes sluggish when multiple programs are opened simultaneously, insufficient RAM may be caused. Each application requires memory to store its data and instructions. As the number of active applications increases, RAM usage rises. Once available memory is exhausted, the OS must rely on slower storage, causing noticeable performing degradation. High memory usage between 18 to 100%. Here, the task manager provides a simple way to monitor memory utilization. If the memory usage consistently remains between 80 and 100%, the system has a very little free RAM available for additional tasks. High memory utilization often results in increased tagging activity, slower response times, and reduced system performance. Monitoring memory usage during your normal workload can help to determine whether a RAM upgrade is justified. Frequent lag or applications crashes. Here, applications that require large amounts of memory may become unstable when insufficient RAM is available. This can result in lag freezing, delayed responses, or even application crashes. Memory intensive software such as simulators, video editors, CAD tools, and development environments are particularly sensitive to memory shortages. Slow switching between programs. When RAM is insufficient, switching between applications feels almost instantaneous because all active programs remain stored in memory. If RAM is limited, inactive applications may be moved to storage. When you switch back to one of these applications, the OS must reload it from disk, causing noticeable delays and reducing workflow efficiency. RAM recommendations. Here, the ideal amount of RAM depends on the complexity of the workload being performed. Different applications place different demands on memory resources. Here, the basic browsing and office, here it takes 8 GB, uses performing tasks such as say web browsing, email communication, video streaming, online learning, and document editing. Users perform tasks such as web browsing, email communication, video streaming, online learning, and document editing generally. Find 8 GB sufficient. Here, this configuration can comfortably support common productivity applications and light multitasking. However, users who frequently open many browser tabs or run multiple applications simultaneously may eventually encounter memory limitations. Programming and multitasking. Here it will require 16 GB. Software developers typically run integrated development environments, web browsers, databases, terminals, debuggers, and collaboration tools at the same time. A 16 GB memory configuration provides enough capacity to support these workloads while maintaining good responsiveness. It also offers flexibility for multitasking without causing excessive memory pressure. Gaming, here it takes 16 to 32 GB. Modern games contain high resolution textures, detailed environments, and complex assets that require sustainable memory, while 16 GB is sufficient for most gaming scenarios. Gamers who stream gameplay, record videos, or run multiple background applications can benefit from 32 GB. Additional memory helps maintain smoother performance during demanding gaming sessions. VLSI CAD virtual machines 32 GB plus. Here, engineers' workloads often process large data sets and perform Computer, computationally intensive task. Here, CAD software contains extensive design databases. Virtual machines require dedicated memory allocations, and EDA tools handle large chip designs and simulations. These applications can consume tens of gigabytes of memory, making 32 GB or more practical recommendations for professional use. AML and large simulation, it requires 64 GB plus. Artificial intelligence, machine learning, scientific computing, and large scale simulations frequently process enormous datasets. Training models, analyzing data, and performing advanced simulation can require substantial memory resources. A 64 GB of large configuration allows these workloads to compute more efficiently and reduces memory related bottlenecks.